Welcome back to your final Algebra 1 video of the year, and this is the final review where I'm going to work out some problems that are like the ones on your final to help you remember what you're doing. You can use your book, you can use your notes. The big thing is you have to show work on the ones that need to be shown work. You cannot just write an answer, it will be wrong. If there is a process that you have to do to get the answer, you must show it. Now, there are a couple things on there. I'm not going to do any of the matching where it's like terminology, like the properties, and I'm not going to do any of the true or false, which go over the rules. You can look those up yourself. And then most of the quadratic formula, which is the last thing that we did, I'm not going to do that. That should be fresh, and there's videos on it. So I'm going to talk about more so the stuff that was in the beginning of the year that you might not have done recently. So I have a few things on here on this board, and then I'll erase it and put one more board up and kind of make it as short as possible. One of the first things we learned is how to simplify things or combine like terms in algebra at the very beginning. This doesn't mean you're going to get x equals something. This just means to condense the problem down as small as you can. So when you're combining like terms, you can only combine things that are the same. Like regular numbers can be combined with regular numbers. X's can be combined with only x's, and x squareds with only x squareds, a's with a's, b's with b's, things like that. So here's an example that I gave you, and the first thing you want to do is order of operations, which means I need to get rid of this parentheses. So I need to distribute or multiply the 6 times x, which gives me 6x, 6 times 3, which gives me 18, and then I'll write the rest of the stuff in the problem. And then I'm going to combine things that I can. As far as my x's go, I have a 4x and a positive, or I have a 6x and a positive 4x. That's going to give me 10x, and I've used those and their sign. When I look at my x squared term, this is the only term I have with an x squared, so it's got to come in my answer. And then lastly, I have 18 and a negative 5, which is 18 minus 5, which would be 13. So simplified, this is what I have. There's nothing else to do after you simplify them because there's no equal sign. You're not solving, you're not factoring, you're not doing anything, you're just leaving it alone. Okay, so if it says simplify and there's no equal and it doesn't say factor, you're just combining like terms. Okay? All right, the next one is factoring, and we hit on this a lot during the year, and we hit on it during the quadratic, so I'm not going to do a whole lot, and some of these are multiple choice, so you can FOIL them out and get the correct answer. However, I picked this problem because it implores two different types of factoring. When I look here, the first thing I need to do is look for a common factor, something that will divide out of all of them. Well, 3 goes into 21 and it goes into 36, so I'm going to divide a 3 out. If I do that, 3 goes into 3 one time, which leaves me with 1x squared. 3 goes into negative 21, negative 7 times, and 3 goes into 36, 12 times. So now I have something that I can factor, a trinomial, with my 3 on the outside. So since this is a trinomial and there's nothing in front of x squared, I make 2 parentheses. Square root of x squared is first. I bring down my 3. And then I say what multiplies to give me positive 12, but adds to give me negative 7. Well, we know 4 and 3 are going to multiply to get 12, and you can add them to get 7. Because you want 7 to be negative, they both need to be negative. A negative 3 times a negative 4 makes a positive 12. A negative 3 plus a negative 4 makes a negative 7. So I put them in here, and as long as their sign is correct, it doesn't matter what parenthesis that you put them in, and that is my answer. If I wanted to check that, I would FOIL the 2 parentheses and then multiply it all by 3. Okay? So that is a reminder there. The next one, there's a solve category, and it talks about a bunch of different problems. They could be inequalities, they could be absolute values, and this one says solve by completing the square, which is something that we've done recently, but I will go ahead and do it anyway. So I'm going to work this one kind of down here, and when we complete the square, when we solve by completing the square, we need to move this on the other side. It just needs to be the x squared in the x term. Okay, so if I add 4, I'm going to get x squared plus 8x equals 4. Okay, then I'm going to take half of that middle term, which is 4, and I'm going to square it, which would be 16, and that's what I'm going to add to both sides. So I have to add, I didn't leave enough room, but I have to add 16 over here, so I would get 16, and then I have to also add 16 on this side, so I would get 20. Then I'm going to factor this side, okay? And that's going to be whatever number I put here. It's going to be x, and that's a positive 4, so I'll put a positive 4 with a squared on it. So whatever number you have here, it goes in there, equals 20, okay? Then we take the square root of both sides, and this will just come out of parentheses and come out of the root, so it'll be x plus 4, and this will be radical 20 plus or minus, but we have to reduce that. Radical 20 will reduce to radical 4 times radical 5, because 4 times 5 makes 20. There is a square root of 4, which is 2, which gets rid of that, and that just leaves radical 5. So plus or minus x plus 4. Okay? Then I need to move my 4 over. So I subtract 4, and I'm left with x equals 4 plus or minus 2 radical 5. I do not subtract it from this because you can only subtract things that have like radicals. It doesn't have a radical on it, so this is the answer, and I'll leave it alone, okay? That is something we've done recent, but that's kind of a little bit of a, I guess probably the most difficult, like you're going to see in this, so I wanted to do one like that. And the last thing on this board is the absolute value equation. And I'm going to clear off a little space here real quick. And I'm pretty sure you probably don't remember how to do absolute value equations. If it has an equal sign, then it doesn't have too much of a different rule than what a normal equation would have. If it has an inequality sign, then you have to pay attention. There's 2 formulas with A's and K's, and you have to do, depending on which way your inequality sign is facing, you have to do one of those formulas. So, but this one is with an equal sign, and basically the first thing you would do is isolate the radical. That means if there's anything out here being added or subtracted, or anything out here being multiplied or divided, you need to move that to the other side. This radical is already isolated. The radical is the, not radical, I don't know why I'm saying radical. The absolute value symbol is the only thing on that side, and so I don't need to do anything there. The next thing you do is make 2 problems, one positive and one negative. So take this out of the radical, 3x plus 4 equals 5, that is positive. The negative one would be put a negative there and change your signs. That makes this negative 3x minus 4 equals 5. And then solve both the equations and you'll get 2 possible answers, and that'll be it. So on this one, I move my 4 over, and I get 3x equals 1. I divide by 3, x equals 1/3. On this one, I add 4, so I'm getting negative 3x equals 9. I divide by negative 3, and x, 9 divided by negative 3 is negative 3. So those are the 2 answers there in the absolute value. I I'm not going to ask you to plug them back in to see which one makes this statement true or if they both do, but that's how you would know which one's the answer. You would put this back in the regular equation and take the absolute value of it to see if it works. Okay? But if you get here, that's fine. All right, I'm going to clear this off and get your last few problems up as a reminder. All right, I got the board cleared off, and here's the last part of our review, just a few little things here and there. One thing I want to talk about is, I don't know why that says that. Parallel slopes. There's going to be a couple questions. I think they're multiple choice questions, and they want you to pick a problem that is parallel to this problem. Well, parallel slopes are the exact same slope. So no matter what the problem looks like, as long as it has a negative 1/3 in front of x, then it's going to be parallel to that line. Okay, it doesn't matter what this number is. It only matters that they are both negative 1/3. So parallel slopes are the exact same slope. If you get a question, which I don't think there's one on there, perpendicular slopes are opposites. You flip it upside down and change the sign. So a perpendicular slope here would be 3/1 or just a 3. Okay, so that's just info to know. All right, what about number lines? Graphing them. So I picked one that's kind of, I guess, like more complex, where you have things, you have 3 parts to this equation. And you solve these like a normal equation, except for you have 3 parts. So whatever you do to one side, you have to do to the other. You have to do to both sides. So I want to get x by itself, so I need to move 1. So it's positive, so I subtract 1. When I subtract 1 from here, I also have to subtract 1 from there. And that's going to give me 2x is less than or equal to 3 minus 1, which is 2. Negative 3 minus 1 is negative 4. And then I still need x by itself, so I divide by 2. But I divide by 2 on all 3 parts. And I'm going to get x is less than or equal to 2 divided by 2 is 1. Or x is greater than or equal to negative 4 divided by 2 is negative 2. Okay? If I put that on the number line, if there's a line down here, it's a closed dot. If there's no line, it's an open dot. So this is a closed dot. Okay? Less than would mean this has to go this way. And this is x is greater than or equal to negative 2. So this one has to go this way. So your graph looks like that. Okay? If there are 3 parts, you're going to have something that looks like that, or your arrows are going both ways. Okay? This is fairly new. We were working on this when school got interrupted and you had to leave, and you finished some of it at home. So just in case you don't remember or you weren't very good about reducing radicals, there are videos up, but I'll hit on it one more time. Pay attention to the root out here. If there's not one, it is a square root. There is no perfect square of 20. There's nothing that can be multiplied by itself to get 20. So what I need to do is to break these down into things that are perfect square. Okay? When I do that, radical 5 and radical 4, or it could be written like this, either way, multiply to give me radical 20. Okay? There is a square root of 4. There's not one of 5. If there's a square root of 4, that comes to the outside and the 5 stays there. Now I have to deal with that x cubed. Okay? Whatever number is out here, you want this one to be divisible by that. So that's a 3. It's not divisible by 2. But I could break it up into radical x times radical x squared. Because when we multiply exponents, we add them. So 2 plus 1 is going to give me the 3 there. And the square root of x squared is x. That comes out there. And since this one has to stay in a radical, it goes right there. And that is reduced. So you reduce them until you can't pull perfect squares out. There's x will never be a square, and then 5 is prime, so there's nothing you can do with that. All right? If you're going to reduce things with fraction, remember you can't have a radical on the bottom. To get rid of this radical, pay attention to the root out there, and this is a square root, so I need to make this a square root. So if I multiply this bottom by a radical 5, I have to do the same to the top. That's going to give me radical 25 on the bottom and radical 35 on the top. There is a square root of 25. It is 5. So right now, I have this. Okay, can 35 be broken down? The only thing that gets multiplied to make 35 is 7 and 5. None of those are a perfect square root, so this is my answer, and I leave it. There can be a radical in the top. There cannot be a radical in the bottom. Okay? The next one is like a substitution, evaluate. Give you some weird equation, but they tell you what the A, B's, and C's, or X and Y's, or whatever it is in there. You just plug it in and solve. So in this case, it says b squared, and that's -4. So I go, my marker's running out here, -4 squared minus 4, and then times a, which would be 1, and times c, which would be a 3. All right, -4 squared would be a positive 16. And then since there's only one negative, this stays minus. 4 times 1 is 4. 4 times 3 is 12. So what I really have is 16 minus 12, which is 4. Okay. Now the last one I'm going to show you is a division problem, and it's a complex division problem. So I wanted to go ahead and I want to find my other black marker because this one is not bright enough. And I'll use a different color, but I don't know where I put it. I tend to walk away with things and then never find them until later. Oh, it's under my rag. Okay. So now we're just paying attention to this. Okay. Divide. And you have this problem divided by this, which means a fraction divided by a fraction, which is complex. But if you notice, these things right here are factorable equations. So factorable equations, you need to factor them and put them in parentheses before we do anything. So when I look at this top part, there's nothing in front of x squared, so this is an easy trinomial. What multiplies to give me 21 and adds to give me -10? I'm going to have 2 parentheses. And 7 and 3 multiply to give me 21. If I want a -10, they both have to be negative. Okay? Then on the bottom, I have 2 terms. This is a square and that's a square, so this is a difference of squares. You've got to be on top of your factoring. Alright, difference of squares, always 1 plus, 1 minus, and the square root of 49 is 7. And then I'll go ahead and write this in. Okay? Now what we would do is simplify some stuff. One, just in this problem right here, I got an x minus 7 and an x minus 7. So now I got x minus 3 over x plus 7. 2, when you divide by a fraction, you flip it and multiply. So if I'm dividing by this, I need to flip it and make it look like this. Okay, that's what you do when you divide by a fraction. Those cancel out, and 1 times 5 is 5, and 1 times x plus 7 is x plus 7, and that is your answer. Okay, so there are some complex ones that take a bunch of different methods that we've learned and put them all in one, which is what that is. Okay, so hope this helps you out. Have a great rest of your day, and God bless.